How to solve block problems using the Newton's second law. Let us read the question here. A block of mass m is placed on a horizontal smooth table. As shown here, this is a horizontal smooth table. On the table, a block of mass m is kept. It is pulled by a force F, making an angle theta with the horizontal. So we apply a force F which is acting at the angle theta with respect to the horizontal line. Find the acceleration of the block, assuming that the block moves only horizontally on the table. That means here it is being assumed that the block will move only in the horizontal direction with some acceleration a, and along the vertical direction it doesn't have any acceleration. That means ay is equal to 0. This is our assumption. Okay. So let's further read the second part of question. What should be the maximum magnitude of the force F so that the block does not lift off from the table? That means the block should not leave contact from the table, it should move only horizontally. So let us solve both the parts of the question. In any type of block problems where we have to use the Newton's second law, the step number 1 is always to draw the free body diagram of the object. So here is our body of mass m, and we have separated it from the floor to which it is in contact. So when we separate the bodies from each other, we say that it is called as the free body diagram. Then on this free body diagram, we will show the forces which are acting on this body. So first we think about the gravitational force. This body will be pulled down by the force of gravity. The force will be m into g. Next force is that because this block is in contact with the table surface, see the base of the block is in contact with the table surface, so the block will actually press the table downwards, and that force is called as normal reaction force. Now, when the block will press the ground with a normal reaction force downward, then the ground will also exert same amount of force on the block in the upward direction. It is because of the Newton's third law. Newton's third law says, if any object applies any force on the other body, then the other body will apply the same amount of force in the opposite direction on the first body. So here the block of mass m is pressing the ground downwards with the force n, normal reaction n, which is the action. Then the ground will exert same amount of force on the block in the upward direction, opposite direction, and that is the reaction force. Next, after this, we look at the force F which is acting at the angle theta with respect to horizontal. So we need to create two components of this force along horizontal and vertical direction. The horizontal component of the force in this case will be F cos theta, and the vertical component of the force will be F sin theta. How do we know that which component should be cos theta and which component should be sin theta? For that, I explain here a simple rule. Suppose we have xy coordinate system, and let us suppose that there is a vector drawn here. Let us say here is a vector, let us give it the name A. The magnitude of this vector is A. Magnitude will be written here as A. Suppose this vector is making an angle theta with respect to the horizontal direction or x direction. So we can create one component along the x direction, and we can create another component along the y direction. Here are the two components drawn here, rectangular components. So the rule is that whichever component is connected by the angle theta with the vector, that will be the cosine component A cos theta, and the other component which will be making 90 minus theta angle would be the sine component A sin theta. Let us repeat the same exercise one more time. We have the vector A, but this time this vector is making the angle theta with respect to the y-axis. So this time what will be the magnitudes of these x component and y component of the vector? So here what will happen, that the component which is connected by the angle theta, that will be the cosine component. So this is A cos theta, and the other vector which makes 90 minus theta angle with the A vector will be the sine component. So if you remember only this simple fact that whichever component will make angle theta with a vector will be cosine component, and the other component which makes 90 minus theta angle with the vector will be sine component. So using the same concept here, we have made our components f cos theta and f sin theta acting on this block. So now we have completed making the free body diagram of our object. Let me simply draw a system boundary so that we will look only at the forces which are acting on the block only. Now you see the figure. In this figure, along the x direction, the force acting is f cos theta, and along the vertical direction, the forces acting are normal plus f sin theta vertically up and mg in the vertically down direction. So step number 1 is complete, making the free body diagram of the block. After this, the next step is to write down the Newton's laws of motion along x and y directions. So Newton's second law of motion is written like this: sigma fx is equal to max and sigma fy is equal to may. Here sigma means summation and sigma fx means summation of all the forces which are acting along x direction, and sigma fy means the sum of the forces which are acting along the y direction, and ax is the x component of acceleration and ay is the y component of acceleration of the block. Now as we know, in our question it is required that our block should be moving only along the x direction with acceleration a. So we can say that x component of acceleration is equal to a, and it is also needed in the question that the block moves only horizontally on the table. That means along the y direction the acceleration must be 0. Ay should be equal to 0. So we now write down the Newton's law firstly along x direction like this: the total sum of the forces which are acting along the x direction is only f cos theta. If you see the figure, only the f cos theta force is acting in the x direction. So the total force, the summation of the total force sigma fx which is along x direction is only f cos theta, is equal to the mass of the body which is m, and ax is the acceleration of the body along x direction which is only a. So we are assuming that the body is moving in the x direction with acceleration a. Let it be our first equation. Then from the second equation, that means applying the Newton's law along the vertical direction along y-axis, sigma fy means the total force which is acting along the y direction. As you can see, normal reaction and f sin theta are acting in the positive y direction and mg is acting in the negative y direction. So the summation of the forces would be written like fn plus f sin theta and minus mg. You see n plus f sin theta, both of these are upward direction, so they are taken positive, and mg is acting downward, so that is taken in negative, is equal to mass multiplied by ay. But look here, ay is equal to 0. Acceleration in the y direction is 0. By solving this second equation, we will get n plus f sin theta is equal to mg. Or we can also find out the value of normal reaction. Normal reaction is equal to mg minus f sin theta. Let this be our second equation. Now question asked two things. Firstly, find the acceleration of the block assuming the block moves only horizontally. So from this first equation itself, we get our answer that acceleration of the block is equal to f cos theta divided by m. F cos theta divided by m. This is the first answer. This is the acceleration of the block. And second thing was asked in the question that what should be the maximum magnitude of the force F so that the block does not lift off from the table. Lift off means the block should not lose contact. the block should not lose contact from the surface of the table. Now, what does it mean? Mathematically, it means the normal reaction should not become zero. Okay, that simply means. So we write down here. We will write down the concept here that if the block should not lose contact from the table, then the normal reaction must not become zero. Or in other words also we can say that when the block loses contact, then the normal reaction becomes zero. Normal reaction becomes zero. So from the equation number 2, we can say this condition: when normal reaction becomes zero, that means normal reaction is mg minus f sin theta. Mg minus f sin theta becomes zero. So therefore we'll get f sin theta is equal to mg. F sin theta is equal to mg, or you can say f is equal to mg divided by sin theta. That means this is the value of the force at which the body will lose contact. Therefore we can say that the maximum amount of force that we should apply, maximum, is mg by sin theta. Means if the force becomes more than sin theta, this implies that if the value of the force becomes greater than mg by sin theta, then the body will definitely lose contact from the surface. So this is the second answer, that maximum value of the force must be only mg by sin theta, otherwise the body will begin to move vertically upward direction. In this manner, both the parts of the question are solved. So I hope that you have understood this question. Kindly press the like button and also press the subscribe button. Thank you.